I'm really excited to be here for our very first European Summit. There were so many good stories I heard yesterday. I hope you all are looking forward to another day full of all things Kafka. You heard Jay speak yesterday about the event-driven architecture, about the stream and table duality. In this talk, I want to focus on the present and future of the streaming platform in an enterprise. I want to take you through the streaming adoption journey, all the phases that an organization needs to go through in order to become truly event-driven. Along the way, I will also share some customer user stories to make this journey real. Okay, so let's get started. Before we look into the journey, let's first look at this pre-streaming world. The pre-streaming world is complex. Data is stuck in legacy systems in various silos. Data moves around in bespoke batches and hence is also processed in a batch fashion. And then there are lots of these point-to-point connections that make the whole data architecture pretty brittle and lossy. Essentially, in this pre-streaming world, the focus and all the time is spent on data plumbing. But that is all the focus and time taken away from building event-driven applications that really drive the business forward. And this isn't just about a move from batch to real time. I really want to focus on the agility aspect of things, how quickly we all as developers can evolve our applications. As you can see here, in the traditional request-response application architecture, there is a tight temporal coupling between the requesting service and all the downstream services that have to respond to that request. This works. This is deterministic. But it is quite rigid. There's a lot of tight coupling between the services. As you try to break your monolith and move to introducing many more services, this also starts to get operationally challenging. So if you compare and contrast this to event-driven applications, instead of synchronously calling into each and every downstream service, this is really different. The application publishes a fact as an event, and then all the downstream services could react to that event and process that event differently. Essentially, the requester does not immutably dictate all the downstream processing. It passes that control over to the event handlers. Why? Because the core belief is that the action can be determined at runtime. It can change depending on the changing business context. As a result of that, event-driven applications, they're much more loosely coupled. These services on the right, they can change, they can come and go, and it does not affect any of the rest of the applications. So how do you move from the pre-streaming world to the event-driven one, and what impact does it have on your applications? It doesn't mean that you necessarily rip out all your request-response applications and put in event-driven ones all of a sudden. But it is much more about significantly supplementing it wherever it makes sense. So your transactions might still be done using synchronous request-response applications. They're deterministic. But then all the downstream processing that needs to respond to that request could be done using event-driven applications. So what's needed to make this transition and this journey to being an event-driven enterprise? It isn't just about adopting a different technology. It is much more about changing the way you think about business and how your data drives your business. It's about making a fundamental shift to event-centric thinking, as you heard in yesterday's talk as well, about continuously sensing, assessing, responding to streams of events that matter to the business. You, of course, do need the technology that drives this, that enables event-centric thinking at an organization-wide scale. In fact, that was a very core motivation we had when we built Kafka, is to enable event-centric thinking everywhere. You know, one of my favorite examples of an organization that is enabling, that is really changing the way they operate is the Norwegian Work and Welfare Administration. They have an initiative they're proposing. They're calling it Life is a Stream of Events. They're trying to put event thinking into practice for all 5.2 million citizens of Norway. Their vision is to make their government work for citizens proactively versus having the citizens worry about every big life event and all the downstream things that need to fall into place to get relevant benefits. Kafka will be at the heart of this event-driven government. Every life event will trigger a message in Kafka that will then trigger a whole bunch of downstream event-driven applications that will respond to that life event. They will do all sorts of things, reducing welfare crime in real time, all the way to actually pushing the relevant benefits to every citizen. We all know that things don't work this way, so NAV's vision is to be a model for all governments, to apply event-centric thinking for the welfare and happiness of all the citizens in the world. I think this is really inspiring. So what I want to talk about next is how do you begin this journey to being an event-driven enterprise? As you might guess, this isn't a one-step fix. It's a multi-phase adoption journey. Each stage has its own unique set of needs that a streaming platform must fulfill. This journey begins with awareness, like any other journey. In this state, you realize that you have a need for real time. You have a need for event-driven applications. You may have even heard of Kafka being the de facto streaming platform, and then you wonder what a streaming platform really does. Is it faster messaging? Is it better ETL? Is it more real-time Hadoop? And the answer is it that it's a bit of all of the above. There are really 3 uses of a streaming platform in an enterprise. The first use we're all aware of is using the streaming platform as a modern pub/sub messaging system. Now, if you squint a little, Kafka is an MQ. But it is pretty different from all the other MQs, isn't it? It's built as a distributed system from the ground up, so it is scalable. It persists data so it can truly decouple your applications. And it also acts as a foundation for stream processing, allowing you to reprocess data in order. Not only is the streaming platform used for pub/sub messaging, but it is also a foundation for streaming data pipelines. Take Kafka's Connect API, for example. Today, you can build these streaming data pipelines in a very off-the-shelf manner because there are so many growing ecosystem of connectors available now. The key takeaway is that Kafka Connect does the hard work that is then available to all the connectors. So this platform-driven approach really makes data pipeline simple. So the third use of stream processing, a lot of what this Kafka Summit talks have been talking about is stream processing, right? And there are 2 ways you can do stream processing in just Kafka itself. There's the Streams API for Java developers who want more control over their code, and then there's KSQL for everyone who wants to do any stream processing. Since we announced it at the last summit and released it, KSQL has been downloaded several thousand times, integrated into analytical tools, has been used to do anomaly detection, streaming ETL, and a whole host of other use cases. I'm hoping that you're as excited as I am now that KSQL is generally available. So all these lenses come together in one technology. It's the streaming platform. Now, once you understand what a streaming platform does, depending on what you're looking to do, whether you're looking for a self-managed solution or not, you might either choose to download something like Confluent platform or just go look for a hosted service. And whichever route you go, in the first 15-minute experience, you're just looking to explore Kafka. You might use a UI, maybe create topics, maybe send and receive messages. You might want to look inside the topic to see what messages look like. Maybe even run a couple of KSQL queries to generate more streams and tables. Or you might just be looking to check the consumer's lag. What you see here is pretty much what you want to do while building your very first app. On the other hand, you might just be looking for a fully managed Kafka in the public cloud, and then you might choose to sign up for something like Confluent Cloud. This is arguably, possibly the easiest way to get started with Kafka, where all you focus on is building applications, leaving all the aspects of Kafka management and operations to the experts. Okay, so that was just introducing the streaming platform, what you do with it in your first 15-minute experience. What I want to focus on now is then you're ready to take your very first steps into production. This might seem a little familiar. Now, there are only two options broadly to take for the first steps in production. The first one is connecting into data that sits in legacy systems, that sits in external data stores, and then moving it into the streaming platform. And the other option is producing new streams of events. So let me take an example about option one, which I've seen quite commonly here. Nordea, a retail and investment bank in Copenhagen, they faced a problem a couple years ago. They needed to be MiFID II compliant. Now, for those of you who may not be aware of MiFID II compliance, MiFID II compliance is European legislative to increase the transparency and faster reporting in European trades. This means more complete audit trails, faster reporting, and for Nordea, being MiFID II compliant meant breaking down silos to get an aggregated view of all the trade data in the bank. But as a result of that, they needed to handle a lot more data as a result. And this was a challenge with the legacy messaging system that supported limited throughput. ETL took up to 16 weeks at times. So to solve these problems, Nordea put Kafka at the center. But then this is not a one-step migration process. You can't just turn off your old system and then turn on Kafka. They actually used a JMS client to create a parallel offload of data, a parallel stream into Kafka. Gradually moved some of the consumer applications over, checked how that is going, and then over a period of time, this will get them ready to move the writes over and perhaps even shut down the legacy system. I want to just mention that this project had a huge impact on Nordea. They were able to reduce platform costs by a huge amount. They were able to drop the turnaround time for analytics from weeks to seconds. And now they're even getting ready to give all their analysts access to KSQL so they can actually analyze and experiment and report on this trade data in real time. So the second option for taking your very first steps into production is producing new streams of events that were previously non-existent or maybe even not possible. The most exciting example that I want to share here of an organization that's doing this is Audi and their connected car initiative. Their vision is to collect event data from the 850 sensors that will live in a car's onboard processor and then pull it into a streaming platform. This will power several functions that are critical to Audi's business. They will be able to identify issues with cars sooner, maybe even reduce cost on repairs. And the most exciting thing is they will be able to alert drivers around hazards, right? To save time, to avoid accidents. Longer term, this data will allow Audi to know how cars behave, how drivers use them. That will in turn inform future product and service offerings. Audi has selected Kafka to be the streaming backbone for the entire Volkswagen group of connected vehicles. So not just Audi, but Porsche and Lamborghini will also be benefiting from this platform. Data will be collected from the cars using MQTT proxies. It will be streamed through the streaming platform into several regional hubs in Germany over the cellular network. Yes, streaming events over the cellular network can be expensive, but Audi believes that the data will be much more valuable than this network cost. And this isn't just Audi. I see this trend across the board in IoT. Here, event-driven architectures, they are the need. They're not a shiny, nice-to-have technology. And they have all sorts of projects that they're putting in place that are producing new streams of events. So as you put more and more applications into production, you move to a stage called mission-critical streaming, right? And capabilities of a streaming platform that really matter in this stage are security and durability. Exactly one's guarantees, ability to never lose a message. Even the ability to monitor event streams across applications and be able to express a data completeness SLA, be able to alert on it. This stage is also about integrated streaming, about breaking silos using Apache Kafka, about fully exploring the stream and table duality, joining streams and tables to integrate data across business units, across silos in real time. You may have heard of ING in their talk yesterday. This is ING's One Bank initiative that they talked about last year. From real-time fraud detection to real-time customer communication, ING now has several mission-critical applications using Kafka that use data in different parts of the bank. For example, for the real-time fraud detection application alone, they built customer 360-degree profiles so that they can do anomaly detection across asset classes, across different geolocations. But then all this did not happen in one go. ING's trust in Kafka has grown over a period of time to a point where today, I'm really excited that what they're doing is they have some experiments in place to move one of the most critical applications in banking over to Kafka, the payments platform. Now, this is still in its early stages, but what mattered to ING before even undertaking this experiment were Kafka's exactly one's guarantees, ability to never lose a message, and the fact that it is battle-tested at scale. So as more and more applications at ING move over to Kafka, they're gradually realizing their one bank vision. I really like what Richard at ING has said is they were active in 40 different countries, but acted like 40 different entities, just sharing profit and loss statements. Kafka is becoming the common thread that is tying the bank together into one unified organization. As you move beyond mission-critical streaming, you enter global streaming. In this stage, your business has grown to a point where you're servicing customers internationally. There's a lot of power in global streaming, but there are several big challenges. Here are some. How do you make data available to applications across wide area networks? How do you serve data efficiently from closer geos? And with things like GDPR, how do you implement data sovereignty rules? And the problem is that the old ways of solving this, they don't cut it anymore, or they're too operationally challenging. We know how this works today. You have a hot standby, you do manual failover that takes hours. You take a global service, you break it into bespoke regional services, and you push all the geo complexity into the application layer. That's not ideal. So the question I want to pose here is, what role can Kafka play to truly enable global streaming? I want to share a thought experiment with everyone. Imagine the ability to deploy a Kafka cluster across wide area networks, where a topic is transparently replicated across a set of regions, where you can write locally, you can read locally or globally. So let's make it a little more concrete. Here's a typical deployment. This is a simple banking application. There are two instances of this application, one in US East, the other in US West. They're both tracking user actions. They're writing events to the same Kafka topic. But now what if you could distinguish the events that originated in US East or US West using, let's say, a namespace qualifier, as you can see on screen? Essentially, what if you could also configure this user actions topic so that no matter where the events were written, they were also globally available and replicated to all the regions? Over time, as you add more and more regions, this gives you leverage. You may have more and more instances of this application across different geo-regions. They're all writing locally so that they don't hurt on latency, but then the topic data is available globally. The nice thing is that here you can support many different consumption patterns, right? You could have some consumer application that just wants access to a particular region's data, like perhaps it's deployed in Europe. You may also deploy, a global fraud detection application in just one of these colos. And then it needs access to the user actions topic that originates in, that has data from everywhere, right? So that you can detect anomalies as a customer moves across different geos. So if this was possible, then our global fraud detection app could just do that by subscribing to the /star namespace for the same topic. Let's not forget data sovereignty. To comply with GDPR, what if you could also specify replication policies at the topic level so that the topic is replicated across different data centers within a single region, let's say within the European region. If that was also possible, then in this case, our fraud detection application now does not get access to data that originated in the European region. Okay, so now this is just a thought experiment, but it's a vision for Kafka I'm really excited about. We have a thriving community and a growing ecosystem. I'm sure we all can get together to really figure out and explore what the world looks like when Kafka is truly global this way. Moving on and coming to the most evolved stage a business can be in on this streaming adoption journey, this is the central nervous system stage. This is the stage your business gets much closer to what I call the digital natives. In this stage, you have a central nervous system. It's powered by a streaming platform, and all the data in the organization is managed through this single streaming platform. The most exciting story of an organization that started from pre-streaming, advanced all the way to central nervous system stage is Royal Bank of Canada. Just a few years ago, they started their streaming journey with option 1 by freeing data from all the legacy mainframes. Today, they have 30+ use cases across 50 different applications, 10 different lines of businesses, all tapping into the streaming platform. It powers everything from their transformation away from monolithic applications to cloud-native microservices. They were also able to reduce the turnaround time for their analytics from weeks to seconds. But the most important thing is they were able to share common data records through, across business units. And not only just that, they were able to share that data with external business partners. Now they have a single source of truth at the heart of their data center. I'm really happy that Kafka is really transforming RBC into a modern event-driven bank. The most interesting takeaway, though, is that all this happened very quickly. Adoption of Kafka at RBC was organic and massive. Within the first few weeks of them taking their first application live, they had 37 different teams asking to use Kafka. That's how you should expect Kafka's adoption to grow in an enterprise. I mentioned the digital natives before. RBC is a story of transformation. There's another type of organization that is in central nervous system stages, and they're the digital natives. The companies that are born digital, so a lot of the data just naturally is expressed as events. The nice thing is that, or the peculiar thing about digital natives is that they advanced to the central nervous system stage very quickly. So Netflix, of course, is a prime example of a digital native using Kafka at massive scale. Today, they have thousands of brokers, and they're processing an astonishing 2+ trillion messages per day. This is a pretty powerful state for a business to be in. The possibilities are immense. We've experienced this before. In this stage, everything happening in the business is an event. It's available instantly to all the applications. The same data that lives in your warehouse is available for stream processing. And the great thing is that all this is possible by also simplifying your data architecture, by deploying a single platform at the heart of your data center, the streaming platform. So as you think about your use of Kafka today, you discuss it with fellow Kafka users, or maybe even you pitch it internally in your organization. See if you can place your organization on some phase in this journey. And then think about how you can help your company, your organization, move to the next phase up until the point where it is truly and completely event-driven. I hope to see a lot more organizations up in the central nervous system stage by next summit. I hope you learned something about this streaming adoption journey. Thank you very much.